Hi, Nitin.
Hi, Abhishek.
Yeah, hi. I think we should start in the next 5 minutes. I've shared links with all the participants. Let's
Sure.
just wait for 5 minutes and then we can start. I'll introduce
Yeah,
you, though the call is recorded, so the recordings will any which ways will be shared with
yeah,
the participants, and we are also going to be putting this recording onto the YT channel. Yeah,
sure.
yeah, sure. Hi, everyone. We are going to be starting in the next 5 minutes. Hello, everyone. Good afternoon, and welcome to a virtual webinar on Beyond Python, the tech stack you need for AI era data science and ML jobs. Today, we are joined by somebody who has been working in the data science and machine learning industry for over 5 years. He has a Bachelor of Statistics degree from Banaras Hindu University and a Master of Applied Statistics from IIT Bombay. We are joined by somebody who is not just an expert, but an expert of experts. So I have with me today Mr. Nitin Mukesh. Hi, Nitin. Over to you.
Thanks, Abhishek. Am I audible?
Yeah, you're audible.
Sure. Do I need to share my camera also?
It's up to you, Nitin, as per your comfort. Yeah.
Sure. I hope you all can see my screen, right?
Yes, please go ahead. Over to you, Nitin.
Yeah, thank you. So, hey guys, I think a lot of people have joined because they want to hear about how to like do data science and ML jobs in these days, where a lot of tech stack has been shifted to Gen AI and large language models. So, a lot of things can be covered for this particular topic, but what I have tried to do is compile a lot of things that can be covered in 1 hour. And obviously, I can share this slide with you so that you can refer this and see what other things can you learn from the stuff or resources that I provided you. So high level, we are going to cover on this webinar is basically how paradigm shift is happening from a classical machine learning to, let's say, LLM and Gen AI, and what are the use cases that other companies are building, and accordingly you can also try to build your projects. The second thing is like the standard industry use cases like uh, just one second. Yeah, standard industry use cases like semantic search or hyper personalization, how these things can be built using GenAI. And in some slides, I've also tried to cover popular architectures like how people these days build a RAG. So how do we build the RAG architecture, and how do you build a agentic AI based solution, or how do you build a semantic search using the GenAI? And as part of this webinar, I've also created a small demo for you guys so that you can also try to see how you can build a GenAI application simply by just trying to do some code and all. And I will also show you the code and how it works. So this is just a simple demo, but it will give you a high level overview of how things works in GenAI and how you can build something on top of a simple thing only. So at the end, I will also try to take some questions if any. The first thing that is there is system orchestration. So like quite a while ago, like people were earlier trying to build a chatbot using the LLMs when the LLMs were very early stage. But right now, this standard thing is not at chatbot, but it has shifted to a multi-agentic system where the agent can take the dynamic action. But like it's not just about talking to LLM, but it can take actions. It can do something for you, and we are all seeing this applications in, let's say, coding model or like Cursor or Cloud or some other cases like Nano Banana, where you can create the images, and you can also introduce agent to do all these tasks rather than doing manually. And we will see some how architecture, like how agents actually work and orchestrate all these things. So, if I talk about the popular GenAI and LLM business use cases that all the companies are building, it's like a high level overview of how what other companies are building. So, like things are really interesting these days because a lot of large language models are open source, and you can build a lot of things easily just by, like, let's say in 2 or 3 days, a prototype and a full running system in, let's say, few weeks or so. So a lot of companies are building production systems like semantic search, where you have something like you search for a query and you want to show results based on that particular query. So these are called semantic search because you want to search the semantic meaning of the query in the given database. So this you can do with the embedding models and LLMs as well. RAG is one of the example where we use semantic search to retrieve the context. We will shortly explore this. Then there are hyper personalization. So, like LLM can understand a large chunk of data at once. So people throw all the data of a particular user, let's say his history or whatever he's done in the past, for example, for an e-commerce site or for some other businesses. And LLM can find useful insights like a user like this or user has spent more time on this, and this helps companies create a personalization view of a particular application. So maybe when you are searching something on Google or searching something on an e-commerce site, and you see things that are closer to what you have seen previously or clicked previously, so these are the applications of hyper personalization. Then really simple use case, a really complicated use case is AI powered code generation, because a lot of models or companies are investing in this particular thing like Claude, Cursor, Windsurf, and some automated coding systems like Replit or Lovable. These all apply AI powered code generation to build application end to end. These systems can use agent as well, and you can also build without agent this system as well. Then the second class of use cases are like a market research, where you use LM to do some market research or search the internet and find the relevant informations for you. And the other thing is like creating insights and interpretation. So let's suppose you have a long or multiple documents from which you want to create the insight or interpret something or find some informations. These are also some standard use cases most companies are working on, as they have a lot of documentations and data and PDFs, and you can obviously dump all these in LLMs and ask something to do for you. Then there are technical reporting. This basically means that you use LLM for uh, generate some report based on the evidence by finding out the internet is basically extension of this particular thing. Then there are enterprise support use cases like RAG, chatbot, where this also has moved to agentic workflows. So basically, you have a lot of documents, and some customers are coming and asking their doubts. Like maybe in these days, Zomato and Swiggy also use agentic support tool when you go and ask for some support related to your order. And these all use cases are going to be some companies are building, and obviously you can do projects on these like by your own and using the open source tools. And obviously, you can also get started in GenAI and LLM. It's not that complicated. So earlier I was talking about this LLM orchestration. So if I like, I will try to cover some of the bits of LLM and GenAI so that you'll have a overview of how this system work. So I told you earlier people were using LLM just for, let's say, chatting something. It can generate text, but like if you integrate databases and if you integrate let's say APIs and some external tools, you can give LLM more power, and it can act like a dynamic agent. It will just try to use the tools, fetch some data from the database, and use the API to call or fetch some data from other sources, and it will give you a context rich technical execution. So that is why LLM these days are using a lot of tools rather than just being a machine learning model which generate text. These uses external tools based on the reasoning or things like where these tools are required. It can reason and call these tools. It can also reason and call informations from databases, and it can give you a rich rich response based on these things. So one simple example is when you ask for your order support on Zomato or Swiggy, they pull your data from the database like what you have ordered, and an LLM see those data. And if you talk, they will also try to call external tools to see when is your order getting delivered and things. So these are a simple way to visualize how LLM right now is not just a model, but it's a group of things like tools, databases, and API. So, if you are new to LLMs, I will just try to summarize at the high level how LLM generates some text. So, let's suppose you ask LLMs to do something and you may provide text, image, audio, or something. Basically, it first tokenizes the your statement. So, let us suppose if the statement is language models are core systems. So, maybe this can act as a one token, this can act as one token, and the LLMs divide this into token, and these tokens have embeddings. So maybe some tokenizer is basically a way to assign some number to a string. So once you provide this, this will go to a model transformer. So this is all LLMs are transformer based model. And I will also show you some popular architecture of the transformer, like how LLM use transformer. And they predict the next token. So let us suppose if I have a language model as core as the input, it will try to predict the next token, which is system, or after system, it's engine. So I also try to build a small visualizer for you guys. So like let's say yeah, this just I built using Gemini. So let's say user give the input the quick brown. Now, as part of LLM, if you just see, the LLM will see these tokens and it will try to predict the next token. So if you see, it will assign some probability to some words, like the fox has the highest probability. So most likely it is going to be the next token of your sentence. And once you do this, this will be assigned this particular thing, and this entire thing will be one sentence now. Now this again go to the LLM, and LLM will again try to predict the next token. So if you just do the same thing, it will take the previous all generated things and it will try to predict the next token and assign probability to all the words. And these are top three words basically. So jumps will be the next token. So similarly, it will create things like the quick brown fox jumps, and it will try to complete the sentence. Now the LLM has been trained on so much of data that it actually understand the context, the semantic meaning, the you can say the language and the way we write the sentence or a story. So that is why the LLM is able to capture these things at the core. And that is how the next word prediction transform itself to, let's say, a code generation or a report making. It just check your insight, the whatever text you have given, and it just try to be a good predictor by predicting the next word. And there are multiple ways to arrange the words to make a sentence. So there are things like top case sampling or temperature, based on how creative do you want to be. So all these keywords have some meaning, like how like at a certain time point maybe you would like to take the not the top word but top keywords and try to make a sentence. So maybe you can take all these three each time and you can create a sentence. So these all go to then like output is generated similarly, and unless and certain stopping criteria is reached. So there are multiple stopping criteria. So there may be max length, like how much tokens you want to generate, or maybe there is some end of sequence token. Maybe some sentence has come to end naturally, like I am doing great, thank you. So it will just like stop generating and it will post process and show you the output. So similarly, images, audio, structure data are all tokenized, broken into tokens, processed by the LLMs or transform model. And similarly, those are used to generate some responses. Now, recently, the transformer architecture has been quite advanced by not just using the simple encoder decoder stack, but there are multiple family of architecture that the current LLM employs. So there are certain models that uses encoder like architecture only. So like BERT, you have must have heard. The BERT is one of the popular model which people use to do the language based predictions, like let's say semantic classification, or maybe next sentence predictions, or some other uh, use of NLP. People generally use BERT. It's a very popular architecture. Then there are decoder style model, which we call basically LLMs, which generate text. So whatever model you see like Claude, Llama, GPT, or this Gemini, every architecture uses some form of decoder only architecture. So in the standard transformer, there are a encoder. So like there is a block of encoder, and encoder inputs goes to the decoder and it outputs something. And there are multiple things in the between these things, but high level you can understand those things. Then encoder decoder architecture are where we both use encoder. So there will be some input will be encoded by a model called encoder, and this goes to the output goes to a decoder stack which decodes and write output. So let us suppose if I am translating from English to French, my input will be English, and the output will be the decoder will output the French sentences. So these are the three class of how we can make three different style of architecture, basically encoder, decoder, or encoder and decoder only. But there are multiple things that people have done, like there is vision transformer for images. Then how people uses multimodal transformer. So basically you take, let's suppose this is a text embedding, there is image ka embedding, and there is some voice ka embedding. People fuse all these embedding and create some layers of neural network which basically generate a text. So these multimodal transformers basically uses a multiple encoder style architecture, and they combine all the output to predict something, like let's say next word or something. Then there are people have recently there are reasoning focused model, like in uh, if you go to this the Gemini, you will see like there are thinking models, like advanced model, thinking level you can on, complex problem solving or standard problem solving. So these all reasoning models are also developed on top of the transformer architecture. So this is high level on how on 20 like in 2017 a transformer architecture was first paper was published, and till now like 2026 there has been a lot of transformations or publications has been done on this transformer architecture, and this is how we have come to era of cloud or Gemini or ChatGPT, which are basically good at understanding the general text and find output. So, like understanding all these things, like how, what are the popular use cases and how a language model works. So there are two kind of work generally involved in the industry. So there is one set of people who are actually creating and training large language models from scratch. So maybe you have been heard about a lot of new models coming, like cloud, let's say cloud. Uh, and then GPT 5.6 is launched yesterday, and some other models are launched. So there are people actually working on the architecture, modifying the training data or loss function, and creating some other new model which beats the earlier benchmark. Now there are second way of working with LLMs is like whatever LLMs has been trained, the open source LLM, you can use those in your task and you can try to solve the real world problems. So one such real world problem is this RAG, which is called retrieval augmented generation. And how, like, when do we use this problem is, let's suppose you have a lot of PDFs and documents and other sources where a lot of text data is there, and you want to write something, or you want to ask something from those document. You can build information. Sorry, you can build application like this. Similarly, let's suppose there are some use cases where you want to search something from a bigger database, 10 million or 100 million entities are there. You want to search something. So in those cases, semantic search kind of problem will be there. Well, like, you can build a semantic search to solve that. And similarly, there are agentic workflows where some autonomous agents are required to do something, like the coding agents are there. If you ask something to write a code, they will like read your files. They will try to analyze what instructions we have given. They will analyze what modifications have been given, done in the past, and they will collate all these things to create a agentic workflow and give you output of a particular code that you require. So I'm going to discuss some of the use cases of this, like how semantic search works and how RAG works at high level, before we go to a real life demo that we are going to see. So, if I explain about how semantic search works, so a basic idea about those LLMs are embedding. So, whenever you have a particular text or you have a particular image, you can convert those into embeddings. So, embeddings are nothing like embeddings are a very simple thing. They are just a vector representation of a particular entity. So, let's suppose if I write the word uh, the it can have a certain vector representation, like in, let's say, 256 dimension. So these are called the embeddings. Now LLMs, if you go to the architecture of LLMs, like from basic, these intermediate outputs, like here or here, these can be used as an embedding, because before generating the text, they output a certain vector, and those vector goes to a neural architecture which predicts the next word. So that is a complicated part, but the high level thing is you can find a bunch of open source embedding model, which given a text, given a image, they will convert into the embedding. Now, one significant advantage of embedding is embeddings have semantic embedding understand the semantic relationship. So let's say I have like 2D plot. So this particular dot is a man. Then if I just try to find the semantic relationship between man and king, it will be very closer, corresponding to woman and a queen. So because the semantic embeddings basically are trained in a such a way that they understand the semantic relationship, and the semantically similar sentences, similar words are grouped together in the multi-dimension. So that is why this 256 dimension embedding is there. We are just trying to understand it into the 2D space. This is how it works. So how do you build a search system is basically you have certain documents. So you have, let's say, image one, image two, and you have k number of images. Now you just convert those all the images into embedding, and you store it somewhere in a database. So these days they are popularly known as a vector database. So I would just like VD vector database. Using the vector database, you can search from using a vector. So let's suppose there is a query and user want to search images based on this particular query. So you will convert this query into embedding by using the embedding model, using the same embedding model basically, and it will try to search which embedding matches with this particular images embedding. So if I want to say, let's say embedding one is the image one ka embedding, and similarly, so what we will do is we will do q dot embedding one. So this is a dot product that you study in vector algebra, and similarly we'll do q with dot embedding two, embedding three, embedding k. Now we know that when you do the dot product, the semantically aligned vectors are having high dot product. So if two vectors are in the same direction, their dot product will be one. So basically, it defines ki query has a direction, embedding has a direction. Now the images which are very closer to query will have the same, almost same direction. So that is how we just sorted by the score of dot product, and we get top k images. So there are ways to do that. You can try to search this using the all the 10 million index if you have 10 million entity, or there are some approximate search like approximate nearest neighbor. This is separately entire topic that we can see. But the high level idea is you convert your images into embedding, you convert your text into embedding, and you try to do the dot product and sort by the score of dot product to see which are the similar top K images based on this query. Now, using this method, you can also build a sentence to sentence search, or let's say sentence to image search, or image to sentence search. There are multiple ways you can do that. So that is what I was telling. You do the cosine similarity and you get the score. I think it's if it's visible. And that is how the semantically similar sentences will be like closer to each other. There are a bunch of applications for these kind of semantic search. Like you can use a build a real life semantic search for a particular company. You can also build recommendations or RAG or image or video search kind of applications. So these are all real life applications which are based on a single simple topic which is called semantic search, where you search based on the vector database and you convert all the entity into embeddings. So this is a semantic search. Then I'm trying to cover the RAG. RAG is basically RAG is basically a intuitive like applications where you can talk, like you can ask something from the document. Now, a high level concept of RAG is also based on this semantic search. So what we do is, let's suppose you have a document of 5 pages. You broke the document into 1 page each. So this will be 5 entity. Now what you will do is you will ingest the text of this particular 1 page into an embedding model, just like we did here. And you will convert those particular 1 page ka text into some embedding even. And similarly you will do with all the pages of the documents. Now next time when the user comes and asks a query, you have to find the relevant pages where the particular query answer is mentioned. And how we will do that? You will just use the same thing. You will use the query, convert it into embedding, and search in the your document space which you have built right now to find top K similar documents, and you give the question and a document to a LLM. So that is what I have written here also. Like first of all, you need to do data ingestion where you break the pages into a documents, like pages into some smaller chunks that we call chunk, and convert them into embedding, and you just store them into a vector database. Now, once user asks a query, what you do is you retrieve the relevant information using the semantic search method, and you pass all these things like the question, the context. The thing is called context that you derive from the embedding. When you search for, let's say, what is the capital of India, and there is somewhere mentioned in this particular document, this is the capital of India, it will retrieve those things and you'll pass the this particular retrieved and the questions to a particular LLM, and LLM will generate a response based on this question and the context from the document. The capital of India is New Delhi or something like that. So, like once you build a semantic search method, you can build a whole bunch of applications which are used in the real world, using the RAG, which is one of the application. So next use case is agentic AI, like how the agents basically use the reasoning and all to tool used to do something. So basically, right now, if you have a simple LLM, it has been trained on some data. If you'll ask something, it will give answer based on the particular data. Let's say if data has been trained till 2025 end of December, it will not know what is happening in the world after 2025. So, but this way the LLM can get old, or you have to train it very regularly, or you have to use recent data to train these things. All the alternate way is to give the LLM some data, the recent data, and how you will do that. So for those we use the tools. Tools basically can be a simple function, a Python function, which when called, fetch the recent news on a particular topic and give it to the LLM. Now, how does the tool works? Basically, let's suppose if I ask what is what are the latest news or what is the weather today? Now, LLM with the help of reasoning, it knows that these are not the things that I would have available right now. Would have to call the tool. So it call the tool with the particular things, let's say the weather in Bangalore or weather in Hyderabad, and it will try to pull the informations from the internet and give it to LLM, which will convert into a natural response. So that is why agentic AI is just an extension of how a particular LLM is used to generate something. It just help the LLM to give extra informations based on from internet or from database. So maybe this tool can also call a database to fetch some resource information about the user. So if high level, if you want to understand how LLM use agents as a tool, agents as a reasoning capability is basically when you ask something, the LLM has a goal to do something. So these are how agentic systems are designed. There are libraries using which you can do that. And LLM try to understand what you are asking. So it will try to see, okay, you are asking about the weather. Now it will plan the task, like how will the task be planned? First, we will need to fetch the weather informations from the internet, and then we will it will give it to the LLM, and then LLM will create a natural response and it will give the output. Similarly, it act basically means that it basically uses the tools to call the real life informations, real time informations using the internet, and it evaluate and give the response to the user. Now if the response has not been given, let's suppose the tool calling failed or the tool was not called due to some error, it will again go to this particular goal and it will again try to execute the same similar type of things, or maybe some different, it will take some different route if it has been planned at that way. So basically, this is a loop. The LLM is in a loop, which basically has the core functionality of take a goal, take a request, and try to execute it based on the different tools that they have. And this that is why when you ask something, you don't have to go and provide the informations about the real-time weather to the model. It will all call the tool and do the similar kind of thing. And that's what you are also seeing when you try to code using cursor or something. It will basically, it calls a lot of tools. It will call the tools to see your files, see your codes, the recent commits that you have done, and accordingly it acts. uh, that is what I was talking about. Ki LLM, you can act as a coding agent. It basically work on the similar principle. You say ki I have to create some REST API and all. It will gather the response like context. It will read your code base, understand documentations. It if it is specified, and constraint and what system do you use, and then it will plan the task. Ki, okay, which file we need to edit, which tools do we need to use. Similarly, once these are planned, these are called the files are executed, codes are written, and then it also create internal test ki whether this particular code has been written successfully or not. Now this all the like this LM as a coding agent is designed this way. Like the maker of this particular agent has specified all those things. Each time someone asks to write a code, do all those steps in a loop. So, and then it, if let's suppose ki here in the running test, it found some issues. Now it will again go to this particular thing and plan and execute and verify. So this is a loop where you give, ask user LM to do something, and it will do something for you by doing going into multiple iterations, multiple loops, and finally it happens. So like all the agents are in some kind of loop. If you want to design the agentic system, just try to see how can we create a loop where the agents do something. These are like how you can use LM coding agent as a in a better way. I think you can refer it to this slide later. So, like till now, what I have discussed, like someone can ask you, okay, there are a lot of things to cover, there are a lot of papers, there are a lot of models, there are a lot of use cases. How should one move in the industry, and how should one build a roadmap in create acting as a GenAI engineer or LLM engineer, or let's suppose AI engineer. So there this is some high level approach that you can use. The basic thing is you have to know some language, like Python is a great start. And like for context, you can read some basic maths like a vector algebra or probability and statistics, because those are used very frequently in all the ML and AI applications, and like how to handle the data. Now, just start with some basic GNI concept, like what is LLM and how, what is the meaning of a token, what is temperature, what is top P, top K, and some in nitty-gritty what those keywords that people use these days, what are those about, or what those means. Then, rather than going into building application, you should invest a lot of times in prompt engineering, because all the applications in some or another way use a prompt or a style of saying how the LLM will work. You will define it through the prompt. Then learn about the embeddings. build some applications on embeddings like RAG or search. And when you build a lot of applications, you can also move to advanced stage of LLMs, which is called fine tuning. Like you want to retrain the LLM or fine tune the LLM for your own some other purpose that these RAG and semantic search can't solve. So for this also in the end, I have given some resources that you can follow. These are some courses and blogs from deeplearning.ai. Those guys make very short courses and they have good amount of projects involved in a particular course. So in each going through each of the courses, you will see how to build a small projects and learn about the things. So we start from the prompting itself, but yeah, you can refer these things in the same order, and you can see this will build a good foundation of GenAI and all. So then you can build the some projects like I talked about. You can build projects like RAG on PDFs, or maybe applications where you can give it a SQL database and you can chat with your database, or some AI code assistant or multimodal RAG. These are all the applications that you can build using open source, and this will be very good for your resume and your applying as a AI engineer role as well, because these are standard industry standard projects that people usually see and ask about how these things works in the real life. Then I think you can also learn a little bit about evaluations, because evaluations are important. So, like let's suppose you build a system, you have to evaluate how a particular system behaves. So, like building a system is just a engineering kind of thing, but evaluations or evaluating the system on a, let's say, a data set or some other ways, there are multiple ways to do this is also very important, and how to scale those particular applications to a large audience. So these are the two important things that are required after you build applications, because evaluations is will be able to tell you in 90% cases or 95% cases this LLM works very well. There are some problems with LLM which is called hallucination, where the LLM sometimes maybe generate some fictional answer that may not exist in a document or in on the internet, but it does sometimes because it has been trained to generate something, and it will always generate something. So there are multiple papers on why does hallucinations happen with LLM. But yeah, the LLM does hallucinate and sometimes give you the some garbage answer. So you need to evaluate in which cases does it perform well. I've also listed some good projects that you guys can try to make, and you can try to start these projects from the day one, because the best way to learn the LMs is to by doing the projects. Now, when I say do your project, it does not mean you go and ask Claude to write a code for a particular AI coding agent. You try to build the nitty-gritty by yourself. Try to identify what will be the workflow, and then try to code each and every parts using LLM or something. But you have to understand the flow end to end. But yeah, these are some good projects which are basically can help you get your resume shortlist, or maybe get a good experience on how GenAI system works. Uh, I always start with the RAG because RAG are very easy. But yeah, you can do some advanced things like multiple RAG or multiple PDFs or multiple sources. These are a good way to get started. So before we go into like I have built a AI powered data analyst. This is LLM powered application that I built for a demo, and it's just a file and some 60-70 line of code. But we will see how this works. But before we start this, I would like to know if anyone have any questions or things that we have covered so far. Uh, Guys, if you have any questions that we have covered so far, you can ask.
Uh, Nitin, there's one question from one of the participants that is semantic search building block framework for recommendation system by any chance?
Sorry. Is this it in
The so
chat? Okay, okay, I was
yeah, it's in
reading.
the chat box. It's not in the Q&A. Yeah.
Yeah, so like how you can build the recommendation system using this semantic search. It has some like you have to do something on top of it, but you can use similar way. So basically, recommendations means that you have done some activity and the system is recommending similar items that you have seen so far. So what you will do is you will build, obviously you will build a vector database, and you will have some items based on which you want to retrieve the similar items. So and that particular item you will encode using the embedding model and try to retrieve based on the each item. So basically this semantic search can be extended to recommendation system by just tweaking the way how you retrieve the items. But yeah, the setup will be same because there will be a vector database involved, there will be retrieval involved. So yeah, you can do that. Okay, we will take some more questions in the end. So this let me explain you what this demo is about. So this is a simple applications where you can upload a CSV data, and you can ask a lot of different questions on the CSV data, and the LLM will give you an output based on the data. So this is the interface. I will try to refresh and show you. So like here in the left, you will see there is an option to upload a CSV file. I will also show you the code and how does it work. So for CSV file, let's suppose I select a simple CSV here that I have downloaded from earlier. Uh, Now, once you have the CSV file uploaded, it will say uploaded file, this AI student impact dataset. Let me just talk about a minute on what is this dataset about. So I just picked it from Kaggle. It is has around 50,000 rows and 16 columns. It is about the how students are getting impacted by use of AI. So like whether AI has some impact on grades, grades falling or rising or something like that. So if you see the data, it has columns like the a student ID, then year of study, whether the particular student is fresher or senior or junior, what category, what major they are taking, like business, humanities, or science and technology. Then they have pre-semester GPA, which is basically before using the GenAI, and one semester they use the GenAI, and after that they also their grades were recorded. Like there is some post-semester GPA also. But yeah, like these are the columns, and there are other things like what is their prompting skills, what what like what is the primary use case they use it for. So let's do some data analysis using the system, and I will also explain how this system works. So let's suppose first up I ask you what are columns in this data. Now as I send the instruction, it will execute some command, and it will show you the results in the right hand side. So it shows it executed this particular command df.columns, and it gives this raw output which goes to the LLM. Like I explained in the RAG section, there are some output retrieved and then goes to the LLM, which LLMs convert into the natural languages. So in the final answer, you will see this saying the columns in data source are this other kind of thing, like all the columns that is there. Now let's suppose I ask some more complicated questions like which is a measure uh, prompt engineering skills in, let's say, junior students. So like there are two columns involved here. There is a year of study, and there is some this prompt engineering skills, and it has to tell if among the junior students which prompt engineering skill is like measure, or you can say uh, uh, prominent. So let's see what this particular system answer this. So So it says that among the junior skills, they are typically at a beginner level. So if you see the prompt engineering skills are, I think it is in 3 to 4 categories like beginner, advanced, intermediate, something like that. Now, let's suppose if I ask you what is the primary use case of GenAI among, let's say, humanities student or business student. Now you are not specifying any columns, you are not specifying any values. It understand your system, it understand your columns, it understand your data, and this is how it answers. So what it has done is it has tried to find the major category, and it has tried to find them like it has first of all uh, filter the data based on the major category, which is business. That's what we want. And we want to see ki among business student, what is the primary use case of LM? Like what use case LM are they using for? So it says among business student, the primary use case for GenAI is ideation. For they use it for ideation. Now, if you see, there are multiple use case of this particular thing. Like some do it for ideation, some do it for some summary rating, or some summarizing or something. So this is how, if you keep asking some questions, it will implement and execute. Like maybe let's say distribution of students as per their measure of study. Now, this system obviously have some limitations that we will discuss. So, if you ask major category, according to major category, what is the distribution of a student? So, you see like STEM has 15,000 student, business has 12,000, and similarly, you can ask different questions. So, let me explain now how this system works so that you can also build and try the system at your own end. So, basically, let me go to the code base directly. So if you see, I have just this particular file which calls the LLM and do the execution. You can try it on any CSB as far as the CSB is small and does not have any system constraint. But I tried with 2 3 different CSB, it works. Now, this how this code base is arranged is in one file you will see the HTML file. This you can get it written by the some LLM or ChatGPT. It is basically the interface that you are looking at. Now the LLM coding part comes here. So whenever you try to upload data, it will just read the data into Pandas CSV format, and it will capture the columns name, because the columns name tell you what this particular data is all about. Now, whenever you ask the questions to LLM, like let's suppose we ask questions, right, like what is the primary use case of GenAI among business students? So based on the columns, it will try to bifurcate the information. Okay, major is coming from this particular column. The prompting skills is coming from this particular column, and I have to do write some code. So we have specifically asked to write a short Python code block to answer this question. Now in the backend, whenever you ask a question, it write a pandas code. It will execute the code and it will capture the summary. Now, once you capture the summary, like let me go step by step. So when this particular code will execute, it will like we will execute this particular thing, and it will give you a demo or raw response. This is how a raw response looks like. It is in tabular format or some other format. Now, when you ask, this is not final thing, because you want the answer in the natural language. So we again construct a prompt which basically says that okay, this is the question, this is the raw result that you got by executing the pandas code, and write a single natural language sentence to deliver this answer to the user. And if you see here, there are some answers written in the final answer. These are very easily readable in natural languages. This is how this particular information goes, and the LLM generates the I'm calling this generate function to generate the natural language answer. Each time you ask something, it will have the code, the answer, and the raw result. How does this happen? Again, it will pass the columns and the questions. LLM will reason and write a pandas code. Pandas code will run. It will run here. Like let me show you how the pandas code run. This is where we run the pandas code, and this exec is itself a function in Python which run the pandas code. Like it is not a self-written. Like I have not written this function. This is available in Python. Once this is there, there is raw result. You pass the raw result to LLM and ask the LLM to write in the natural language. So this system had some constraint. The constraint is once, let's suppose if I want to ingest multiple CSB, I won't be able to do it because I have not provided the support. Similarly, you can also integrate user history. It means that okay, whatever the user has asked before in this particular chat, the LLM can refer to that particular things. Then what you other way you can do is you can introduce agentic thing. Agentic, let's suppose the system written some code and the code execution failed. So the answer here will be there will be some error visible here. Like let's suppose if I ask some tough question, let's say plot the distribution of major category against GPA. So this is a complicated questions, like maybe LLM try to write some code, or maybe try to plot something. We do not support plot currently, but you can also build a, see, there is some error, like it try to plot it something, but we do not support the plot. There are some library that is not installed. So you can write a agentic system to kind of, let's say, do in a self correction loop. Maybe if the package is not installed, it will install the package and then execute the code. These are all doable because this is how modern system does that. And other thing that you can do with this particular system is you can try to execute the code in a protected environment. Let's suppose LM retain some command that can access your system file and do some, let's say, change on that. You don't want to do that. So that is why there is something called sandboxed code execution, where you execute the code in a protected environment. And obviously you can add the multiple CSV support. So this is how simply you can build a system which, when you upload a CSV, you can ask the LLM to do a bunch of things in the natural language. You don't need to know the pandas to analyze this particular data. So I will provide the GitHub link to also for this project also, so that you can try it in your own way, and you can try to implement these improvements, or and you can build it into a real life projects for your resume and all. So that is why I just listed down the ways you can modify this code. Maybe you can convert this code into end-to-end data analyst. You can maybe convert this into a end-to-end pandas writing or coding assistant system, like it's write code for you given a data, and you can execute those code to see the result. Some, it can also act like a, let's say, a report generator. You provided a CSV and you can define, you can ask in the LLM itself here, given the CSV, do this kind of thing, do the data analysis, give the distribution of each columns, give the bivariate distribution of each column, and introduce everything into a sheet or something. So this also can be extended into this way. Obviously a lot of work will be required. And maybe you can also convert it into a multimodal analyst, where you user also upload some image or some chart or some other PDFs and ask questions based on the CSV file. So a single system these days are not like they are intended to do. They can be extended into multiple different ways, where you can do different things using the same system. So this is how you can utilize this particular thing. At the end, I will try to just say that whenever you build a GenAI application, just don't get stick to the application itself. Try to evaluate it. Try to see if the particular system is working on all the kind of inputs, or it has some limitations. If you can quantify that into some numbers, like there are ways to do that. You can do that. You can create a curated data set and try to use LLM to verify the output of your system. And at the end, obviously you can also fine tune your model if those particular use cases required to do so. There are a whole bunch of use cases where you can fine tune a model, and there are a whole bunch of use cases where standard model, LM trained model will work. And there are things like prompt tuning, where, let's suppose I have written this prompt in a single shot, but you can obviously try to catch a different version of this prompt, which will can give better results or not give errors in some input. So obviously there is a real thing called prompt tuning, where you don't work with a single prompt. You start with a single prompt, you try the multiple version or variants of that particular prompt, and you stick with a particular prompt which acts or work in a lot of cases. So that is called prompt tuning. So obviously try to do these things before sticking to a prompt. And yeah, like that's all I could say for this particular slide. If you have some questions or anything, I will be happy to answer.
Do we have any questions for what all is covered in the session?
Or you can type your questions in the chat. If you have any questions or any kind of doubts, I'll be happy to answer.
Nitin, there's one in the Q&A box by
Yeah.
Prerna Tyagi. Yeah.
Okay, so Abhishek, is there a way to share these documents or the informations?
Yes, Nitin. So Yeah, I'll be sharing that, the recordings and the GitHub links and the, I would say, presentation with the participants.
Sure, sure. Oh, one more thing that I would like to say is in this particular thing, I've used Gemini endpoint that is very easy to get and try a lot of for a lot of different of AI applications. But if you want to use your own LLM, like let's say if you has a system that support it, you can go on Hugging Face and you can try to download some let's say some uh, low computing model or some GGF file which are easy to support on let's say 16 GB RAM system, and you can also build your own local LLM and try to do those things. So I've just used the Gemini API just for simplification of the system, but in a lot of cases, people build their own, use their own local LLM, and you can try to see which LLMs are good, or try to see which LLMs is supported by your own system. That will be a good learning exercise too.
Okay, so Nitin, we have like one question from Manish as well. I'll just paste it into the chat box.
Mhm.
I'll just paste it into the chat box. So this is one of the questions, and then there's another one.
Okay, so for prompt tuning, what I would like to say is, let's suppose there's a better way to write prompt. So you give the like you open ChatGPT or Gemini or any LLM, and you define what task you are trying to do, and ask them to give some prompts variants, like two, three different variants of the prompt. Like how will you evaluate which prompt is working better is by creating a data set. So what we generally do is, if your problem is quantifiable, you will try to create a data set, and on each prompt you will run those particular prompt and get the output from the LLM and evaluate against your data set. So a simple example is like let's suppose I am using LLM to let's say tag or training data. So what I will do is I will build a kind of a small data set, which is let's say you give some rows and LLM gives you some output. Now you do it for let's say 10 100K input rows and you got some output. Now what you will do is you will sample let's say 100 or 1K rows, and you will try to manually label them or get it labeled by some human labeler, and you will see based on 3 4 prompts variants that the LLMs gave you, which prompt variant is able to get maximum accuracy out of these things. So this is just one example. There are ways to think how can you quantify your metric into some numbers by using a small data set, and this will help you to say, let's suppose in 95% cases one of the prompt works better, you will say that this is the best we can do with a different version of prompt that we try. There are other ways like recently some auto prompt tuner applications are involved. So what they do is they will write prompt by in your behalf. You give some data, like we can build a prompt tuner by ourselves. We can give a data and you can ask LM to try different prompts, try different examples, analyze those examples, and see which prompts is working better. So there are multiple ways you can do that. And coming to a second question, like guardrails, evals, and memory allocation method, I would say a lot of enterprise LMs comes with a guardrail. Like if you are using API for let's say ChatGPT or Gemini or some Claude, they comes with a guardrail, and you have like ways to assign some guardrails according to their API documentation. You have to see. Evals, I would say, are the different problems of different evals. So let's suppose if you are doing semantic search, you will maybe do an evals on relevance, whether the items retrieved are relevant or not. Let's say if you're doing RAG, the evals will be most kind of, let's say, uh, is the answers provided by the model after retrieving is accurate or not. So it will be a factual thing. So there are ways you can think about that. Uh, Now, though, your last question is, I think, is how to build a system that is core of all other AI use cases. So, I would say go to a project, pick a project, go to its depth, build end to end. Like let's suppose if you pick any project out of these things, a good one maybe let's suppose AI voice AI assistant, or let's say AI data analyst that we saw. Now you don't make it at a surface level, you go end to end, like you build the entire system, you build the handle the error correctly, you can do multiple things, like you can upload multiple CSV files, you can let's say also plot some results. So a system that is built on the surface will not looks great in your resume, rather than if you build some system end to end, and it uses a lot of things, like it uses security also, it uses agentic, let's say agentic also, it uses multiple systems and it works very perfectly. You have built kind of a complicated system that works well. That is how to like you can do that. But all the systems, some are like more or less uses LMs in some way. If you invest your time on building any system by going into depth, it will really build a cool projects for your resume.
Uh, Thank you, Nitin. That brings us to the end of this pre-webinar, the session. And a big thank you to our audience for bringing so much of enthusiasm. Recordings as well as all the resources, the GitHub links, as well as the slides which have been covered will be shared on your email addresses in the next 2 to 3 days, that is in the next 48 to 72 hours. Until then, stay connected. Please follow Nitin and please follow me so that you can be well aware of all the free webinars that we're going to bring to you. Thank you, everyone. Thank you, Nitin, for this wonderful session.
Thank you, Abhishek. Thank you guys
Thank
for
you.
attending
Thank you,
this.
everyone. Happy weekend.